Hi there, today we will learn more on polynomials and we want to learn more on long division. Lecture 3. Example 1. If we want to divide this polynomial with two linear divisors, how do we do it? Since the divisor is consisted of two linear expressions, we can simply just expand those two linear expressions and we'll get a quadratic expression. So this will be our quadratic divisor. So just write that divisor outside of the long division symbol and write the polynomial inside the long division. But notice that our polynomial is just x power 3 plus 1. There's no x power 2 and x power 1 terms. So we have to add x power 2 and x power 1 terms. But we cannot just simply add them like that. Since the value is not there, so it means that the coefficients of this x squared and also x power 1 is just 0. Because 0 multiplied with x squared is just 0 and 0 times x is just 0, so it means that we are adding nothing. So that it's the same as the original polynomial. But why do we still have to add these two terms? It's because you don't want you to confuse when you want to divide with this quadratic divisor. So this will be your polynomial. Alright, so let's try to divide it. Remember the steps. Step 1. Take the first term in the polynomial. Take whatever the term is. If there's a number in front of that x cubed, take that number as well. But there's no number, so we just take x power 3. And then take the first term of the divisor, x squared. Now, divide these two terms. And what's left is just x. Put this x as your first term of the coefficient. Next, multiply this x with the divisor term 1 by 1. X times x squared is x power 3. X times x is x squared. And then x times negative 2 is just negative 2x. Remember to put a minus sign outside and a big bracket there. Why do I want you to write that big bracket? Because if you don't, you might just do careless mistakes, because you might think this minus is only for the first x power 3 term, but it's actually for all of the terms inside the brackets. Next, just subtract those two expressions. Make sure the first term is 0. X power 3 minus x power 3 is 0. If it's not 0 here, that means you have done something wrong at your quotient part. Next, 0x squared minus x squared is just negative x squared, and then 0x minus negative 2x is just positive 2x. Next, we want to eliminate the first term. So the first term that we have here is negative x squared. So take everything, including the negative sign. So negative x squared need to be divided with the divisor, which is x squared. Now divide these two terms and you get negative 1. So write this negative 1 on your quotient part. Okay, so negative 1 times x squared is negative x squared. Negative 1 times x is just negative x. Negative 1 times negative 2 is just positive 2. Remember to bring positive 1 down. And then put a negative sign with the brackets there. Make sure the first term is 0. Negative x squared minus negative x squared is 0. And then just subtract each of the terms behind it. 2x minus negative x is positive 3x. 1 minus 2 is negative 1. Up to this step, can you proceed any further? So this is 3x. Can you divide 3x with x squared? Well, this is where you have to stop. When do you know when to stop? is whenever the degree or the power of the remainder is less than the degree of the divisor. So that's where you have to stop. What is the degree of our remainder now? So the degree is the highest power of x of the remainder. So the highest power of x of this remainder is x power 1. So since x power 1 is less than the degree of the divisor, which is x squared, so this is where we have to stop our long division. So what happens with 3x minus 1? So this means this is our remainder. So that's our remainder. So remember, whenever the degree is still equal to or greater than the divisor degree, you still have to do the long division. But when the degree of the remainder is less than the degree of the divisor, you have to stop. Now, the question wants you to find the form of px equal to dx times qx plus rx. So that's what we have found. We have found the dx that we have used is here, is the divisor. So our quotient is just x minus 1, and our remainder rx is this 3x minus 1. So just write your answers according to their orders. So this is the divisor, this is the quotient, and this is the remainder. Okay, now let's look at the next example. I want you to try this example out. Make sure your polynomial has all of the terms of all of the degrees. So let's say if this is x power 3, you have to include x power 2 and x power 1 term as well. Okay, but since there's no x power 2 and x power 1 in this polynomial, you have to add in 0 of x squared and 0 of x. And then divide with this quadratic divisor. Okay, feel free to try this example out. After you're done, try example 3. Example 3 is a little bit different because this question wants you to find the quotients and the remainder. The previous question wants you to write in that form of the formula. But now the question just wants you to find what's the quotient and the remainder. So make sure you write the answers clearly. And then try example 4. And also example 5. There's something that I want you to look at in example 3, 4, and 5. Look at their divisors. Their divisor is linear. Remember the rule of thumb that I have mentioned in example 1. Remember when to stop. You have to stop whenever the degree of the remainder is less than the degree of the divisor. So look at our divisor now. The degree of our divisor, or the highest power of this divisor, is x power 1. So the degree is 1. Can you guess what will be the degree of the remainder for this question? Well, the degree of the remainder must be less than degree of the divisor. Not equal, but it must be less than. So what is the degree less than degree 1? Of course, less than 1 is 0. So that means the degree of the remainder would be x power 0, or is actually a constant. So make sure when you solve example 3, 4, and 5, because all of them has linear divisors, you need to have constant as their remainder, not linear as their remainder, as in example 1. Look at example 1, the remainder is linear because the divisor is quadratic. So when the divisor is linear, the remainder will be constant. 1 degree less than. Let me show you what I mean in example 3. Okay, so now we are going to use the long division And remember, you have to add in 0x squared and also 0x term there. Okay, now to divide it, you have to take the first term, x power 3, and divide it with the first term of the divisor. Divide these two, and your answer is x squared. Put it on top. Next, x squared multiplied with the divisor 1 by 1. You get x power 3 minus 3x squared. Remember to put a minus sign in front and the brackets. Next, x power 3 minus x power 3 must be equal to 0. If it's not 0, check your quotient. Okay, next, 0x squared minus negative 3x squared is equal to positive 3x squared. And then bring the next term downwards. So we have to eliminate 3x squared now. Write everything there, 3x squared. Don't just take x squared, but take the whole term, including the coefficient. So write 3x squared, divide with x. So you can divide these two. The answer is 3x. Put it on top. Next, multiply your 3x with the divisor 1 by 1. 3x times x is just 3x squared. 3x times negative 3 is negative 9x. Write a minus sign in front and put a brick bracket there. Subtract the terms 1 by 1. 3x squared minus 3x squared is 0. 0 minus negative 9x is positive 9x. And then bring the last term downwards. So now we want to eliminate the first term, which is 9x, divided with the x term. So take notice that here we have reached to a linear remainder. But why don't we stop here? We don't stop here because now the divisor is linear. So remember, the rule of thumb is that the remainder must be 1 degree less than the degree of the divisor. So if the divisor is linear, the remainder cannot be linear as well. The remainder must be less than linear. So what's less than linear? Of course, it's just a constant. So this means that you are not done yet. So keep on dividing. 9x divided with x is just 9. So put 9 on top. Next, 9 times x is just 9x. 9 times negative 3 is negative 27. Subtract these two terms and your answer is 0 as the remainder. So write down your answer clearly. Write down the quotients because the question wants you to find the quotient. So qx is equal to x squared plus 3x plus 9, and then the remainder is 0. Write it clearly like this. Okay, what does it mean if the remainder is 0? Remember your tutorial 3 says that the remainder will be 0 only if the quotient and x minus 3 are the factors of the polynomial. Now look at example 6. We also want to find the quotient and the remainder, so we have to do the long division. And now the divisor is quadratic because the highest power is 2. The highest degree is 2. So remember the rule of thumb. If the divisor is quadratic, what will be the remainder? Will the remainder be a linear expression or a constant? It's just 1 degree less than the divisor. So if the divisor is quadratic, so 1 degree less than the quadratic or x power 2 is just x power 1. X power 1 is linear. So quadratic divisor implies that we will get linear remainder. Okay, now let's do the long division. Write the polynomial inside and the divisor outside. But hold on, look at the divisor carefully. Same rule applies here. Remember, when the polynomial does not have all of the terms of the degree, you have to add in. For example, in example 3 and also in example 1 and 2, like this. So if you have only x power 3 minus 27 as your polynomial, you have to add in x squared and also x term, but with the 0 constant in front, right? So also the same as your divisor. make sure you have all of the terms included. So this is x power 2. The next degree after x power 2 is x power 1, but it's not here. So what you have to do is make sure you don't write x squared minus 3 because you will tend to do careless mistakes if you do that. So it's better if you add in one more term, which is x power 1. But remember, if it's not there, it's just coefficient 0 and then minus 3. Okay, now let's solve this. So 2x power 3 divided with x squared. 2x power 3 divided with x squared. Cancel everything out and you're left with 2x. Put it on top. Multiply 2x with each of the terms of our new divisor. So 2x times x squared is just 2x cubed. And then 2x times 0x power 1 is just 0x squared. So write that term, 0x squared. And then 2x times negative 3 will be negative 6x. Well, if you don't add in this 0x term here, I'm sure that you will do a mistake here at this step. Okay, so just add in that 0x squared term so that it's easier for you when you want to subtract. And you can see each of the terms one by one. So 2x squared minus 2x cubed minus 2x cubed is just 0. Make sure it's 0, and it must be 0. If it's not, something wrong with the quotient. And then negative 7x squared minus 0x squared is just negative 7x squared. 7x minus negative 6x is just positive 13x. Next, bring 15 downwards. Should we stop here? Well, we cannot stop yet because the degree of our remainder now is negative 7x squared, which is the same degree as our divisor. So we cannot stop until the degree of the remainder is 1 degree less than the degree of the divisor, which is x power 1. So we can still continue on solving this. Write negative 7 on top and multiply negative 7 with all of the terms one by one. Negative 7 times x squared is negative 7x squared. Negative 7 times 0x is just negative or positive 0x. And then negative 7 times negative 3 is positive 21. Subtract these two expressions. Make sure the first term is 0. 13x minus 0x is just 13x. 15 minus 21 is negative 6. So, do we have to stop here or can we continue? Check the power of the x. The highest degree is x power 1. Remember, x power 1 is less than the degree of x power 2. So this means we have to stop here. So what is 13x minus 6? Well, that's the remainder. So write down your answers clearly. Qx as 2x minus 7 because quotient is on top. Next, remainder is the last terms below your long division. Okay, so hopefully you can understand and try to do the other examples. Thank you and good luck.